A breathtaking montage of space. Rockets launching, astronauts floating in the International Space Station, ISS, and vast galaxies filled with stars, set to a dramatic soundtrack. Imagine stepping into a spaceship, traveling at nearly the speed of light, and return home only to find that hundreds or even thousands of years have passed on Earth. Sound like science fiction, right? But in reality, time does not tick at the same pace for everyone. The faster you move, or the stronger gravity you experience, the slower time flows for you. This is a bizarre and mind-bending truth of time dilation. And today, we're going to explore how time works differently in space. One cut to the narrator in the studio with a digital screen showing Einstein's portrait. Our understanding of time took a massive leap in 1905 when Albert Einstein introduced his special theory of relativity. Unlike the idea that time is absolute and flows at a fixed rate, Einstein proved that time is flexible. It stretches and contracts depending on speed and gravity. This is called time dilation, and it's a fundamental part of how the universe works. Speed and time. The faster you move, the slower you age. To a digital animation of two clocks, one stationary on Earth and the other moving at high speed in space. Let's break this down with a simple example. Imagine we have two identical clocks. One stays on Earth, while the other is placed on a spacecraft traveling close to the speed of light. When the spaceship returns after a few years, the astronauts on board will find that their clock has recorded less time compared to the one that stayed on Earth. They have aged less than their Earthbound counterparts. 3. Cut to archival footage of cosmonaut Sergei Avdeyev on the Mir space station. This isn't just a thought experiment. It has actually happened. Russian cosmonaut Sergei Avdeyev spent 747 days aboard the Mir space station, traveling at about 27,360 kilometers per hour. Due to his high-speed motion, he aged about 20 milliseconds less than those of us on Earth. While this difference is tiny, it proves that time dilation is real. The twin paradox, a journey into the future. For a split screen showing two identical twins, one staying on Earth and the other boarding a high-speed spaceship. This leads us to one of the most famous thought experiments in physics, the twin paradox. Imagine two identical twins. One remains on Earth, while the other boards a spaceship traveling at near light speed. When the traveling twin returns after what feels like a few years to them, they might find that their sibling has aged decades or even centuries. The twin who traveled at high speed would be much younger than the one who stayed on Earth. 5. Cut to a 3D animation showing the spaceship accelerating toward the speed of light and time slowing down on board. This isn't science fiction. It's a direct consequence of Einstein's relativity. The closer you get to the speed of light, the slower time moves for you compared to people who remain stationary. But speed isn't the only factor that affects time. Gravity plays a role too. Gravity and time. How black holes can freeze time. 6. A 3D visualization of a black hole bending space-time. Now, let's talk about gravity. The stronger the gravitational field you experience, the slower time moves for you. This is called gravitational time dilation, and it happens because gravity warps the very fabric of space-time. The best example? Black holes. 7 show a visualization of an astronaut approaching the event horizon of a black hole. If you were to fall toward a black hole, an observer watching from a safe distance would see your movement slow down, as if you were frozen in time near the event horizon. From your own perspective, however, everything would appear normal. But if you somehow survived and managed to escape, you would return to find that thousands or even millions of years had passed in the universe. 8. Cut to a scene from the movie Interstellar, showing the planet near the black hole. A great cinematic representation of this is in the movie Interstellar. The astronauts visit a planet orbiting a massive black hole, where time moves incredibly slowly. For every hour spent on the planet, 7 years pass on Earth. While exaggerated, this concept is rooted in real physics. Everyday time dilation, GPS satellites, and time correction. 9A visual of GPS satellites orbiting Earth. You might be thinking, this is all fascinating, but does time dilation affect our everyday lives? The answer is yes. GPS satellites orbit Earth at about 20,000 kilometers per hour because they're moving fast and experiencing weaker gravity than we do on the ground. Their onboard clocks run slightly faster compared to clocks on Earth. 10 cut to an animation of GPS signals being corrected for time dilation. If we didn't account for this difference, GPS devices would be off by several kilometers each day. That means your navigation system would lead you miles away from your destination. Scientists constantly adjust for this time difference to keep GPS systems accurate. The ultimate time machine. Is time travel possible? 11A visualization of a futuristic spaceship traveling close to the speed of light. With everything we discussed, you might be wondering, does this mean time travel is possible? Technically, yes. By traveling at speeds close to the speed of light, astronauts could move forward in time relative to people on Earth. However, traveling backward in time is a different story. 12 show visuals of wormholes and theories about time travel. Some theories suggest that wormholes, hypothetical tunnels through space-time, could allow time travel to pass, but there's no experimental evidence yet. Still, the idea remains one of the most exciting possibilities in physics. Final. What does this mean for the future of space exploration? Cut to a scene of futuristic spacecraft exploring distant planets. As we look toward the future of space travel, understanding time dilation will be crucial. If humanity ever embarks on interstellar voyages, astronauts will return to find Earth vastly different from when they left. Mastering time manipulation could open doors to exploring the farthest reaches of the universe. A montage of stars, planets, and human space exploration. Time, as we know it, is not constant. It bends and stretches in ways we are only beginning to grasp. Whether through high-speed travel or the immense pull of gravity, time dilation reveals a universe far more fascinating than we ever imagined. With that said, thanks for watching, and until next time.